Department of Physics, which was established in 1958, presents St. Joseph's massive open online courses on the topic optics as skill effective course. Myself, Dr. C.H. Praveen Babu, Assistant Professor, Department of Physics, St. Joseph's College for Women Autonomous, Vishakhapatnam, Andhra Pradesh, India, as a skill effective course on the topic optics. The subtopic is Chapter 4, Polarization. Chapter 4.4, Quarter and half wave plates and optical activity. Learning outcomes from this topic: understand polarization manipulation, angle of rotation concept. Quarter wave plate. Consider the case of a calcite plate cut with optic axis parallel to the surface as shown in the figure. It has been shown that when a plane polarized light falls normally on a thin plate of uniaxial crystal, here calcite crystal is taken, cut parallel to its optic axis, the light splits up into ordinary and extraordinary plane polarized lights as shown in the figure. They travel along the same path but with different velocities. The velocity of extraordinary ray is greater than the velocity of ordinary ray. As a result, a phase difference is introduced between them if the thickness of the calcite plate is such that it introduces a phase difference of pi by 2 radian or a path difference of lambda by 4, then it is called quarter wave plate. To calculate the thickness of such a plate, we proceed as follows. Let T be the thickness required for such a plate if mu O and mu E be the refractive index of the crystal for ordinary and extraordinary waves, then the path difference between O and E waves is mu OT minus mu ET is equal to mu O minus mu E into T. Since mu O is greater than mu E in calcite crystal, for a quarter wave plate, this distance should be lambda by 4. Mu O minus mu E into T is equal to lambda by 4. From this, the thickness of quarter wave plate T is equal to lambda by 4 into mu O minus mu E. Half wave plate. If the thickness of calcite crystal plate cut with its face parallel to optic axis is such that it introduces a phase difference of pi or a path difference of lambda by 2 between ordinary and extraordinary waves, then it is called a half wave plate. For a half wave plate, mu O minus mu E into T is equal to lambda by 2. From this, thickness of calcite plate T is equal to lambda by 2 into mu O minus mu E. Optical activity. It is observed that certain substances like quartz, sugar crystal, etc. rotate the plane of vibration of a plane polarized light passing through them. In figure, a quartz crystal on which plane polarized light is incident with its plane of vibration parallel to its optic axis is shown. When the plane polarized light travels inside the crystal, its plane of vibration is slowly rotated about the direction of propagation. In the emergent light, the vibrations are in some other plane. This rotation of plane of vibration can be demonstrated by the following experiment. In figure A, two nickels are set in crosser position. The field of view is dark. Now a quartz plate cut with its face parallel to optic axis is introduced in between the two nickels as shown in the figure B. The field of view is not dark, but slightly rotating the second nickel N2, that is, for some different position of N2, the field of view is again dark. This suggests that the light merging from quartz is still plane polarized, but the plane of polarization has rotated through certain angle. This property of rotating the plane of vibration of plane polarized light about its direction of travel by some crystal is known as optical activity. This phenomenon is known as optical rotation, and the angle through which the plane of polarization is rotated is known as angle of rotation. Some observed facts about optical rotation. There are two types of optically active substances. One, the substance which rotates the plane of polarization in clockwise are called as dextrorotatory or right-handed. The substances which rotate the plane of polarization in anticlockwise direction are called as laevorotatory or left-handed. The amount of rotation theta produced by an optically active substances is proportional to its thickness T traversed, that is, theta is directly proportional to T. In case of solution or wafers, the amount of rotation for a given path length is proportional to the concentration C of the solution or wafer, that is, theta is directly proportional to C. The rotation varies inversely as the square of wavelength lambda of light employed, that is, theta is inversely proportional to lambda square. Thus, it is least for red and greatest for violet. The total rotation theta produced by a number of optically active substances is the algebraic sum of the rotations theta 1, theta 2, theta 3, etc. produced by individual specimens, that is, theta is equal to theta 1 plus theta 2 plus theta 3 plus so on. The rotation in the anticlockwise direction being taken as positive and that the clockwise direction as negative. Optical activity. The ability of a substance to rotate the plane of polarized light is a key property used for characterizing chiral molecules in diverse fields. It finds applications in chemistry, biochemistry, and material science, allowing for analysis of enantiomers, drug development, and material properties. In the field of chemistry, enantiomers identification and purity analysis, synthesis and reaction monitoring, structural analysis, and in the field of biochemistry and pharmaceuticals, drug development and enantioselective medicines, enzymatic studies. In the field of material science, optical properties of materials, chiral liquid crystals. In the field of general applications, sugar industry, quality control, optical rotation, and polarimeters. From this chapter 4.4, quarter and half wave plates and optical activity, we have learned how to apply waveplate principles, application of optical activity.